Good afternoon, all. Let me start again by thanking, of course, the CREDAI East team, especially Rachit, Arihant, and Rahul, for giving us this opportunity to share with you how the PropTech ecosystem is helping the real estate fraternity address the challenges and opportunities with the use of technology. So, Arihant, thank you for sharing about what we do at Brigade Reap, why the accelerator was started. And we are blessed to have some really exciting startups which are actually solving these problems, identifying issues with the real estate fraternity head on. Now, very quickly before I introduce the startup itself, I just wanted to sort of share maybe another minute. I'll share for about another minute or so. The real estate fraternity has constantly been hit by one tsunami after the other, right? It was just beginning to come to terms with the multiple reforms and changes brought in by demonetization, RERA, and GST. And while the sector was on the growth trajectory for the last few years and was likely to emerge stronger, but the current Corona crisis, I'm sure, has put brakes on its growth momentum. Now, the way we look at it, right? Every crisis there is a potential to inspire innovation. Simple innovations backed by technology can actually have an impact. And the startups that we will be talking about today, the startup that will be presenting, these startups can help you implement something today and tangibly have clear identification of revenue generation, cost optimization for you to take sort of help of them today itself. So with that, given that we are already at about 4:08, let me start with our first startup. So today, as Arihant shared, we have 4 startups that we will share with you how sustainability can be used very effectively in the real estate domain and demonstrate real savings. So with that, I would now like to invite Abhilash.
Sorry, I'm interrupting.
Sure, Rachit.
The Q&A.
Yeah.
So if you can just mention about that also, so that people know exactly when to ask their questions.
So what I was thinking, I think based on our earlier discussion, let the startups present and then let's take Q&A, maybe about 5 minutes of Q&A. They can, of course, type the message as well or ask, unmute and ask. And we'll try and keep it to about 5 minutes, and time permitting thereafter, once all the presentations are done, if there are any more questions, we can open it up.
Okay, so at the end of every startup presentation,
yes,
you can ask the Q&As.
Correct.
Then again, we'll start with the next one.
Right? Yes. Yeah.
Okay. Yeah.
Okay. So with that, Abhilash, on to you. Let's talk about VGOT. So unmute yourself and let's start with you. Okay.
Can you see my screen?
Yes, I think we can.
Okay.
Go ahead.
Okay. Hi, everyone. My name is Abhilash. I am one of the founders of VGOT Utility Solutions. The problem that we are looking to solve has been very well documented. Our cities are running out of water, and in the next 10 years, we will have only 50% of the required amount of water. Right? And when you think about this problem, there are only 2 ways you can solve this. Either you increase the supply or you bring down the demand. And this is exactly where VGOT focuses its energy. We help bringing down the demand in buildings by up to 50% using our IoT-based water management platform. Right now, I specifically focused on the word IoT because what that means is there are 2 aspects to it. There is a hardware piece that collects information, and then we take this data, we take data from this hardware and put it onto a software and put this in the hands of users, which helps them make real-time decisions. So I'll talk about the hardware piece first. So what is on the left-hand side of the screen is a traditional water meter. This has been around for more than 50, 60 years. There hasn't been too much innovation as far as the traditional meter is concerned. And then before we started this, I asked myself a question. This is not rocket science, installing a water meter in every house. Why are we not? Why does every house not have a water meter? Why are we not paying for our own usage? That's what will make people more accountable. So after talking to about 100 different residential properties, the first thing that we found out was that it is very manual intensive because somebody has to go into each duct, get the reading, do calculations offline to understand how much you're actually consuming. The second was the data that comes out of these devices are also not accurate. Let me just elaborate a little bit more on this, right? So how a traditional water meter works is you'll have water pass through it, you'll have a turbine that rotates, and then you have this counter on top which tells you how much water you have consumed. But now what happens is in the plumbing line, you have both water and you have air as well. So this turbine will rotate irrespective of water or air, and therefore your data is not accurate. The second challenge is when you close a tap, pressure is formed and then water also flows backwards. Now, unless you have a separate device called an NRV or a non-return valve, this water will keep going back and forth, but your counter on top goes only in one direction. What this essentially means is that you keep getting counted multiple times for the same water that you are using. And the third challenge is that when you have very low flow, that is not enough velocity to turn this turbine. So therefore, the data is not accurate. And when the data is not accurate, people are not willing to pay for that usage. They don't have any belief in that system. So that was the second challenge. And the last thing is it's also tamper-proof. If you take a magnet and bring it close to this, you will be able to tamper with the data. So those were the design problems that we identified. And based on those design problems, we've built India's first IoT-based ultrasonic solution device. So this is the actual device. That's the image on the screen. So what we've done is we've done away with this turbine. That turbine was the central root cause for the entire problem of the data, of the tampering, of the reverse flow, all of this, right? So what we've done is we've built an ultrasonic solution. How this works is we have two piezo elements in each end of the device. We know this diameter. This is a fixed diameter. This is a fixed distance. We calculate the time difference in nanoseconds that it takes for water to go from point A to point B. And this will give you the exact volume of water that you are consuming. Now, we've also gone ahead and certified this by the government. We will be able to give you over 99% accuracy at a one drop level. So that is the cleanliness of the data that comes out of the device that we have. Now, also the other challenges that I mentioned, the reverse flow, water flowing backwards, that's not an issue anymore because when I go from point A to point B, my time difference is positive. But when water hits here first and goes backwards, it will become negative. We'll automatically subtract that and give you true flow. Airflow is not a problem because I don't have a turbine. It will just go pass through unnoticed. And very low flow is also not a challenge because I'm able to give you 99% accuracy at a one drop level. There is no possibility of tampering it, none of that. You will get a notification in real time. And also we've sent out a strong message by not putting a counter on top. What this means is you don't have to go to the device. The data will come to you on your mobile phone, right? So this leads me into the software piece, the application layer of it. So once we collect this data, now we're able to deploy the sensor anywhere, individual apartments, at a campus level. If you're buying tanker lorry, your STP output, your WTP input, your WTP output, how much is there in your storage tanks. Essentially, you're able to audit your water in real time using this platform. The other thing is also that we will detect leakages and you also have the ability to remotely shut this off from your mobile phone. So that's the second thing that we've built. It's a pulse-driven solenoid valve that gets put in just before the sensor. The third thing is also we've made it convenient. For this to become a practical solution that everybody uses, it has to be extremely convenient. So what happens now is all the consumption is measured. You will get a bill on your mobile phone. You can pay that bill also from your mobile phone itself. So this will give you a bird's eye view of your water consumption across the property and help you manage the entire property better. So this is our IoT-based water management platform. Now I'll talk to you about what happens when people use our solution. So this is a use case of one apartment in Bangalore. It's an 80 apartment property. They're buying tankers. Their monthly expense on water is about 160,000 rupees, which averages out to about 2,000 rupees per apartment. Within 3 months of installing our solution, and you can see this is Feb, March, April. This is in the beginning of summer. It went from 160,000 to 75,000. Right? Savings of over 1,000 rupees per apartment. Not only do they save on the water, they've also saved because once you reduce your consumption, you will save on the electricity required for pumping, the electricity required for treatment, and also in the wear and tear of your equipment. So this is as far as this happens in every single property that we have deployed our solution in. in the long term, the environmental impact is what I'd like to also bring to your attention. Today, we design our buildings for 135 liters per person per day, and people are actually using more than 200 liters per person per day. Now, in all the deployments that we have, we are now able to prove that you can design for 100 liters per person per day if you have the system installed in your buildings, right? And what this means is it impacts your future cost of construction, because at 135 defines how big your sump size is, how big your tank capacity is, how big your pump capacity is, your pipe size. Everything depends on that 135. Now, if I'm able to bring that down to 100, you will see a lot of savings in your cost of construction in your future projects. Also, the social impact of running out of water. Now, people tell you save water. We give them an actionable way to start saving water right now. We have deployed this in over 30,000 apartments and another 40,000 apartments in progress right now. We also manage about 30 million square feet of commercial real estate, which has overall saved over 1 billion liters. Actually, 1 billion liters is a little old. We are pushing on 3 billion liters right now. Also, we work with some of the largest clients in the country. In Bangalore, we work with Brigade, with Purvankara, with Salarpuria, Mahindra Life Spaces. Also in the East, we have started off on a couple of projects. The tallest building in Kolkata, the tallest residential building actually in India right now is in Kolkata. It's called the 42. We've already deployed it there. Our other client from Bangalore, which is ITC, they're also setting up their green center there. So we're also deploying over there. But outside of this, there are a couple of large opportunities that we're currently working on as well in the East. I'll quickly talk about that as well. This is at JUSCO. So Jamshedpur manages its own water, and JUSCO is the utility company that manages the water for the city of Jamshedpur. So we've already deployed in 2 buildings, and it's looking like it's going to become a pan-city this thing where they'll use the entire city's water measurement will be tracked using our solutions. Similarly, a railway station in Karnataka, we're managing 1 railway station, and as we finish deploying this, we'll start moving into other railway stations across the country. So, I mean, what this indicates kind of to us is when we first started about 5 years ago, we were focused on 1 building, but now the strength of the system is now being showcased, where we're able to take on city-wide implementations, entire railways-wide implementations, and we already have certain projects to showcase this. So this is as much as the solution, as far as the solution is concerned. We've also got a lot of recognition from across the country, including from the Prime Minister, for developing an intuitive and low-cost water management platform. I'll also quickly finish by letting you know what it costs you, right? So we want this to be accessible to everyone. So we've actually broken the model down from just selling you a device and moving on to becoming a SaaS-based water management platform. What this means is we will give you the product for free. The client only pays for installation, whatever cable, conduit, plumber, electrician, all that. And then there is a monthly subscription. In the residential complex, it works out to 149 rupees per house per month. It doesn't matter if it's 2 bedroom, 3 bedroom, 4 bedroom, 149 rupees per month. This will take care of service, maintenance, app upgrades, Amazon service, web services, payments, everything, right? Once you put it, it's my responsibility to make sure that the system is working. Otherwise, you do not pay me that monthly subscription. So this is our business model. We're currently a team of more than 90 people, almost 100 people, and we're expanding rapidly. So this is about us. This is a brief overview of VGOT. I'll be happy to take any questions that you might have.
So I wanted to add a couple of points, but I think there's some questions that have come in. So let's go through that. Some information on the capital cost. So I think Abhilash, you answered that. Giridhar, I think the cost, as he mentioned, there is a 149 rupees per month per house cost post the deployment. Abhilash, you want to add anything more there?
Yeah, so that's exactly what it is. So it starts at 149 rupees. We have 3 plans, 149 rupees, 199 rupees, and 349 rupees, depending on which plan you choose. And in the commercial real estate space, it works out to 20 paise. You normally charge a CAM of between 10 and 15 rupees. We charge 20 paise. So it essentially pays back for itself almost immediately. That's how it works.
So just to clarify, I think there's a question on that. It's 149 per flat, not per device.
No, not per device, per flat.
Correct. Okay, so that was Anand's question. There's another
question. Where are you seeing these questions? Sorry, where are you seeing these questions?
So go to the group chat. Just open the chat window. Yeah, I mean, if you could, that'd be great. Are you able to see it? Otherwise, I'll read the next question.
Yeah, actually, if you can, I'm not able to right now.
What impact do you see the same will happen for places where there's no cost associated with water? Also, in terms of percentage, what is the wastage of water in distribution versus consumption?
Yeah, so it's just like, I'll talk about the loss in distribution versus consumption. Most buildings, there is at least a 25% from what comes in, right? You have sources from tanker, borewell, municipal water, rainwater, STP recycled water. What comes in to what is finally consumed, there is about a 20 to 25%, closer to 25% than 20%. Once you start tracking this, most of the properties that we deployed a solution in, it's closer to 12 to 15%. The remaining, you cannot do much because there is evaporation, there's water in your pipelines already, and slowly over a period of time, you will have minor leakages. You'll have WTP water that goes wasted through backwash. So all that together, if you're at 10, you're at a very good spot. I mean, the building's working optimally. What was the other question, Apul?
So yeah, what impact do you see the same will happen for places where there's no cost associated with water? So I think you should share more about, where you don't measure, the costs are higher and so on.
Correct. So what happens what happens when we deploy where there is no cost of water? Like I know in the East, it's not as difficult as it is in Bangalore or in Chennai. What happens is you will have electricity cost. You are pumping that extra water. So your STPs, your WTPs, all of them consume electricity. So you will save some on that. And also on the wear and tear of all the equipment. Your STP, you have breakdowns because you're overusing it, right? So you will be able to bring that down. And in your future projects, you will save on the deployment. You will figure out what the ideal design is supposed to be.
So there, I would just like to add, Appa Swami Builders out of Chennai, right? I mean, they are now one of the largest builders in Chennai, and they promote, and Abhilash, correct me if I'm wrong, the fact that their complexes, their apartments are managed by VGOT. And from what I understand, again, designed for 135 liters earlier projects, but they are now looking at, because you're down to about 102 liters per person per day kind of consumption, right? So do you want to elaborate on that
Appa Swami, we started our first project in 2016. They gave us one project to work with. Today, we are a default in every single project of theirs. So with this, they've been tracking their own consumption for all the apartments over there to see what the per capita consumption is. And they are exploring if they can work on reducing the cost of construction, improving on the design using this data right now.
Okay.
And it's actually been quite standard like this across all the other projects. Most of the clients that we have worked with, we start with one and then we're almost a default in all of their other projects as well.
So I still see some questions coming, but given that we are already at 4:25, Abhilash, what I'd recommend is look at the chat and see if you can respond. Some questions are fairly simple, what diameters and all, and stay back so that if we have time, we can answer a few more towards the end.
I'll just quickly do the diameter in just like 30 seconds more.
Okay.
So we do everything from 15 mm, 20 mm, 25, 32, 40, 50 is all our own devices. For the bigger sizes beyond that, we use third-party devices, but we're able to collect the data from that and plug it into this platform.
Great. I would like
size is not a limiting factor. Yeah. Everything else respond here.
Thanks. Do respond and do stay back. Okay. Yeah. With that, thanks, Abhilash. So with that, I'd like to move to our next startup, which is again a very interesting one, talking about sewage treatment plant. So with that, Tarun, if you can turn on your video on, and Abhilash,
I'm on.
Stop sharing.
I'm on. Can you see me?
Yes.
Yes.
So
all right.
Yeah, the floor is yours.
All right. Good afternoon, everyone. I'll straight move to the presentation. Let me make it bigger. Yeah, we go. Apul, can you see the screen one? Then I'll go on.
We can just see you so far. Can you share the slides?
Can you now?
Yes.
Okay, let me make it bigger. All right. Is it on? Okay, I mean,
Yes, you can.
right. All right. So now, good afternoon, everyone. My name is Tarun Kumar from STP Technologies. I'm the co-founder here. So I'll be talking in the next 10 minutes about the innovation that is a zero power, zero operator sewage treatment technology. Little old technology, but I'll just take you through that. So let me start with the burning lake, my favorite picture, because this is a lake that's burning. And I live near this lake, so that's why it's more close to me. So it's a lake in Bangalore. The lake burns every 7-8 months because the sewage that comes in, and that's exactly why I put this picture here. Last time it burned, we got the fire engine to douse it. They couldn't stop it, and we got army to douse it. It took 14 hours, 1-4, to douse the lake fire. 5 months now, and three more months now, it'll again burn again. So we're all waiting for it. Right. So why is burning is 140 million liters of sewage is coming to this lake every single day in Bangalore. 140 MLD. And this is like something like 40% of Bangalore when the flush is straight comes to the lake. And it's just not a Bangalore thing. Lake is more a metaphor. I'm sure every city has got a similar issues, which I'm aware of. So why the sewage is coming is because the STPs, sewage treatment plants in the city is completely broken everywhere because of the complexity, the power, and the operator requirement. That's how it. So everyone has got STP. It work for 6 months, 1 year. They switch it off. They dump to the drain, and all drain reaches the lake. So this is the issue in Bangalore, and I guess this issue everywhere. Like the minister says, 70% of India's STPs are broken. 70%, and it's a very conservative number. Its number is around 90 or 80. Now, why is this broken? Because the current technology, what you see here, is what you get today. It's based on aerobic bacteria. You need a lot of motors, power diffusers, a lot of machinery, moving parts. It works very well if you have a very good operator, STP operator. So STP operator is the key, assuming you put a good STP. And the key point here is they use aerobic bacteria. So it needs air. So you have to blow air into this. So you need an air diffuser, what you see in the left. And since you need a diffuser, you need a blower motor, which needs a lot of power. So that's a trick. So as long as the power is on, blower is on, and when you blow air through the fecal matter, the whole area will smell. You can't get out of it. So you need an exhaust fan to take the gas out somewhere else. So it's very complex machinery. And that's another motor to add bacteria every 1 hour in the system. So that's another motor. So an operator, STP operator works very well. Make sure it all works well. In case the STP operator is not good, or one of the motors are broken or diffuser not working, then you have trouble. Any tech you take, it comes in different names, MBR, SBR, MMBR, is all same. Blow air through fecal matter, number one. Number two, add bacteria every 1 hour. So this is the fundamental premise which we're trying to see how we can disrupt. So we came with a different solution. I'll just come to that. This is how it looks like. Let me explain this. It's a civil structure, 3 stages, completely made out of cement and steel and pipes. There's no moving parts, no motors. All the bad water that you flush comes to the tank 1, and then it moves by gravity to the second tanks. It's based on a function called anaerobic digestion. Anaerobic digestion is a very old technique. Septic tanks use anaerobic digestion. So we use a very advanced anaerobic digestion, patented device, a 12-step anaerobic digestion, which is based on a cow stomach. If you look at a cow stomach is one of the world's best anaerobic digestion machine. Very, 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 very powerful. You can even take grass and you can milk out. Everything gets digested in the stomach. So same thing we copied, we replicated. With the help of Biomimicry Institute, Montana, USA, they are the technical partner. They're experts in how do you maximize the cow stomach efficiency. So same thing we've done a whole lot of piping mechanism, very integrated mechanism, but it's all easily doable. We help the builders and developers make the actual STP on the ground using very detailed drawings and support from Bangalore. And that's how we execute. So tank 1, stage 2, stage 3. We have created our own custom bacteria we put in the bottom of the STPs. So stage 1, all the fecal matter within comes in, and by gravity it moves to the second tank, and from second tank it moves to the third tank. Now the tank 1 is where you need the maintenance once in 2 years. So you have to remove the sludge once in 2 years. You call a normal septic tank and remove sludge once in 2 years in stage 1. That's only maintenance required, no other maintenance required at all. So we supply the some certain parts of the stage 3. There's some media involved that we supply. We supply the drawing. There's certain exhaust fan some element, exhaust fan with no moving parts that we supply. So we call a kit, eco-STP kit. So what we say is buy the kit from us, and then you put the concrete and STP is ready. Now, after the stage 3, we need to use something called a tertiary treatment system for better filtering and all. So that we use a plant filter to do it, or you can use such charcoal filter. There are multiple options to do that. So this is the water quality you get after the treatment. This is a live photograph. It's not a touched photograph, real live photograph before and after. We have on YouTube the actual videos of this, how it looks like. Now this water quality, what to do with this? I can either use for gardening straight, or you can use you can put a charcoal filter, or you can make it better. You can put an ozonizer and make it much better. Or one client is putting an RO machine, and you can use it for drinking. So it's currently getting deployed. So we have to see how many people drink, but at least all the residents said they at least use for bathing to start with. So the main heavy lifting of treating to this quality water is what you get. Beyond that, it's up to us or client to make it to any purity what you get. This is done completely natural. What you get in the right side is done zero power, zero operator. Beyond that, it's up to us to, that may need some power. If you want to put RO machine, for example, needs power. This is how the STP in construction looks like, which I call the guts of STP, where you see the pipes, a lot of contraption, way to do it, but nothing, no rocket science, no great complexity. If you just follow the diagrams, it's a very detailed diagrams. You have to follow step by step, and you get the STP up and running. And once it's all done, this goes underground, and you use a top area, fill it up completely. And you can be 100% reuse the top area. This area, there's no smell, is completely sealed at all. There's a vent pipe that goes out, that you take it out and let out at the top of the building, but the whole area is completely sealed. I'll show you some pictures. This is how it looks like after the STP is done. This is one of an apartment in Bangalore. So what you see in the entrance is STP below the ground. It's completely sustainable, integrated along with the building. So what you see is the manholes, are the manholes which you see. Once in 2 years, one of them has to be removed, and there's no other maintenance. The plant filter, what you see in the left, is it does the cleaning for the water. The water flows the roots and water gets cleaned. So it's completely holistic. There's nothing to be done. Absolutely, once in 2 years here to do it. They use the water for flushing. So when you want to use for flushing, especially now with the COVID crisis, you have to disinfect it. You have to either chlorine or ozone, one of them, to disinfect the thing, and that's a different component. But there's no other maintenance, nothing required. They don't have a STP operator. A security guard is there. That's all. That's all you have. It's another example of what I have is another apartment. The kids are playing around, and below that is an STP. So as you see, there's no smell. Kids are playing. Is integrated as part of the system. Is as holistic you can get. We say it's built for generations because there's no moving parts. It's standard civil structure. Let's look at the features. The topmost features is no minimum load. Is a very, now with all the COVID crisis, any STPs what you take, minimum, they need 50% minimum load, at least 30% minimum load to operate. Ours needs no minimum load, not minimum. We need one toilet to work. So one security guard uses the toilet. That's all it requires. It just works. So you don't need a minimum load requirement. You don't need to wait for a 30% occupants to fill up your properties to start operating an STP. So many places, till the 30% load comes, it is all goes to septic tank, and septic tank does they fill it, they call the septic tank and get it all delivered. But here, ours works just with just one toilet. And obviously, no, as I mentioned, no power, no operators. We got all the approvals from Pollution Control Board. So CFE and CFO, we have all approvals. No smell. And lastly, ROI, return on investment, is less than 2 years. So I know it's a very powerful number, but so if you send me your requirement, how many flats you have, I can work out a specific customized ROI sheet for you. Typically it's 1.5 years, but 2 years max. That's all it is. So it's one time you put the money, and less than 2 years is the ROI. These are my customers. We are now in 9 states, 51 projects going on. We have one in Assam, Shivangan Estates in Tinsukia, that's nearest to there. We have one in Patna, Lucknow, Delhi. South, lots in South. We treated some 60 million liters water so far, which we track daily in our dashboard. And we saved power of 98 megawatts so far. And these are the customers. We have Tata Steel and others, and all happy customers. And I mean by happy or delighted customers, right? This is another happy customer in Patna. He's day yesterday he put in his Facebook saying that Sakar is a large 2,500 unit township coming up in Patna. Is saying they're reducing the footprint by using EcoSTP technology. So is their advertisement? I just put it in the here's a Facebook ad. So they use many of our clients use EcoSTP as a selling point. For one of our clients, we got a United Nations recognition. If you go to the site, you can see only UN logos there because you are reducing the cost for end user. Right? I can the typical running cost something is like 25 rupees per month or something like that. Very low compared to, as I said, less than 2 years ROI. So this is a Sakar thing. Customers, we have if you go to YouTube, we have 8 testimonials in YouTube by 8 CEOs. One said you are a Tesla. One said you are 70% cheaper. It's all customers saying. I'm not saying this. It's a CEO, customer CEOs like you. We only put CEO recommendations in YouTube. They don't have to give a recommendation, but they are given in YouTube. It's all in public. Lastly, I have this recognition slide. Lot of I just try to cram it into one slide. Whole lot of them. We have a DIPP, Government of India approval. We have a patent on this technology. We have selected by Agni as a best practice. We Royal Academy of Engineering UK selected us for a fellowship program. It's a 1-year fellowship program. United Nations selected us as a best practice for SDGs. We completed to 6 SDGs. In fact, we go to United Nations link. You can actually download the report from UN site itself. And lastly, we are very proud to be part of the MODA, the Museum of Design. Atlanta is going to host an innovation next month. So it got delayed because of the COVID thing. So maybe it get delayed. So first, the only innovation in Asia they selected. So they're going to host our design in the museum itself as an exhibition. Well, that's my last slide. Yeah, I tried to make it in time.
So I think I know you're just about on time. So I think there are some questions have started coming in already.
Certainly.
One is quality of water outlet in terms of BOD, COD, TSS, and is the process approved by the Ministry of
MOEF,
Environment, Forestry? Yeah,
yes,
MOEF.
yes, that's right. Yeah. So Ministry of MOEF has approved is we have a CFO for 10 years. Clients have got CFO for 10 years, etc. BOD 10, COD 50. We comply to all the norms. Absolutely. That's a without that we can't even enter because that's a fundamental premise. Then only you can sell STP. We have to be compliant. And this is, and you can make much better, as I said. Now BOD 10, if you want to make it improve it, then you would add additional filters that cost money, that cost motors, but filters, but you can improve that. And that's a very filtering technologies are well improved. It's very mature. We got very good mature ultrafiltration, multiple technologies available which are very well matured. Whereas the broken piece is what we address, that the blowing motor, adding back every 1 hour, blowing through fecal matter, that pain is taken away us. But as is, we confirm all the norms.
The other question is, does it fulfill the standard? So maybe very briefly touch upon the PCB thing, Tarun, if you can.
Yes, PCB, there are 2 compliance. One is a CFE. When you apply for a CFE, you have to apply for us with a form. And so we give the documentation of EcoSTP. They go through it and they say, okay. And then once done, then they come and visit and then do the CFO. So we have customers who got CFE and CFO.
Okay, and I think what I'll do is, given that we are at about right on time, I think there are a few questions which are specifically about 100 KLD plant, 40 KLD plant.
Okay.
What I request is if you can just respond back, because I'm sure a lot of people would have that question for their specific needs.
Okay.
I think it'd be good. The other is, I think you should, we'll have, I think there's some other questions on area comparison. So what I request, I think Mr. Anand Niotia is asking the question about area comparison between other STP technologies and yours.
Yes,
so maybe just take maybe 30 seconds to explain that, Tarun, and then we'll move to the next one.
Right. So area is a good question. Area, we need around double the area space of the other STPs. So double. So STP takes 100 meters, we need 200 meters. But the beauty is the 200 meters is completely recovered, 100% recovered, because as I showed you in the picture, it's below the ground, below the playground, below the road. All of our customers, the space is 100% utilized. But this needs space. So you need a one-time, you need to dig the space, put this all contraption in, and then you close the space. But technically speaking, we need 2.6 square meter per KLD. That's a space requirement. So you can just double it, more or less. 2.6 square meter per KLD is a requirement. So you can do, and you can do any shape. You can do around the building. You can do square. You can do rectangle. So it be how the building contours we exactly dwell with that. There's no, so we call it belt STP. Some places we have a narrow long STP around the building. So wherever spaces we just melt in.
Tarun, I think a few more questions. What I recommend is maybe if you can create, share this presentation, we'll share it with Rachit and team and they can share it with others. Maybe add a couple of case studies basis the questions that are coming.
All right, sounds good. Yeah.
Okay, and stay on. I think if we have time, we will have a few more questions for you.
Yeah.
Thank you so much.